Hello, welcome to the New Stack Makers, a podcast where we talk about at-scale application development, deployment, and management. The New Stack thanks the Cloud Native Computing Foundation for sponsoring our podcast from KubeCon plus Cloud Native Con in Austin, Texas. Learn more about cloud native technologies and the projects that are defining modern application development, deployment, and management at cncf.io. Hey, it's Alex Williams, the New Stack here at KubeCon, here for day 2 of the conference, really, for the major keynotes. And a lot of discussions that we've been having here have been about the maturity of the ecosystem overall, and I think that's really well reflected in this CSI, which is the storage interface, really, and for container storage interface. And the gentlemen I'm here with right now are 2 of the major people who have been behind the development of CSI. So could you guys introduce yourselves, and then we'll just get started in the conversation.
Sure. My name is Goutham. I'm with Portworx.
I'm Clint Kitson, and I'm with Code, the open source initiative at Dell. And we are definitely major contributors on the coding side, but it's really important as a setup for this to say, CSI is being led by the container orchestrators. So Mesos, Google with Kubernetes, Cloud Foundry, and Docker. There's a lot of different people involved that are all very large contributors.
I think that's very important, right? That's very important to say that this is not just about Kubernetes. This is about, this really, to me, reflects this kind of next generation thinking about how you create abstractions, really, so you can integrate storage into different services. Would you agree with that?
Yeah, it absolutely is about making giving the end users a sense of reliability. It's testable code now, in the sense that when an orchestrator wants to support stateful applications, they don't have to have 10, 20 different in-tree drivers for 10 or 20 different backend storage platforms. It becomes a very difficult test and support matrix, and it leads to unreliable production issues. And CSI, really what it does is it provides that abstraction layer so that the orchestrator can be independently tested, and us as a storage providers, we don't have to do the work of integrating with 3 or 4 different orchestrators.
Yeah, I think when you look at the history of it and extensibility for infrastructure in the past, it's been really interesting, how different projects or products have emerged. And if I look backwards 5 years or 10 years, when, say, virtualization and VMware started to change the market, it was really the partners that were enabled through extensibility that helped grow that ecosystem. So it's one of those critical components, as you build these platforms and you make yourself open and extensible, to bringing more and more value to customers so that they can adopt the workload, and it really just brings a megaphone essentially to the projects and products that are core to infrastructure.
That's interesting. It almost seems like the CSI helps really kind of facilitate the growth in a way, because if everyone is trying to build out their own drivers, right, all the time, right, you can't really have considerable scale.
Exactly. It accelerates what customers have been asking us in the ecosystem for, which are give us an easy way to deploy stateful applications in a container orchestrated environment. People are trying to deploy applications like Cassandra, Postgres, and if they have multiple different storage backends and they need to have multiple different drivers that they need to test and interoperability with, it just slows the entire process down for us as a development ecosystem to develop products, for them to be able to deploy it and consume it. So yeah, CSI makes that, it accelerates how fast storage vendors can provide support for a container orchestrated environment.
And we're here at KubeCon right now, so I think we need to talk a little bit about Kubernetes. And in that space, Kubernetes is a little bit different than the other orchestrators. Kubernetes, from the beginning, as they've embraced volume functionality, has really brought the drivers that we're talking about directly into their code base. base. And I think it's actually created a very good user experience where it's very easy to get Kubernetes up and running with any of the storage platforms that are supported by Kubernetes or included in the code base. But I think where it's caused problems is how quickly that the Kubernetes code base can move forward and how bugs are triaged, etc. And so this extensibility and something like CSI is very important for making sure we have volume functionality, but making sure that Kubernetes doesn't have to maintain the bug fixes for all the different platforms that are supported. So having a really good user experience is what we're really driving after, and that's one of the key components of CSI that we're trying to ensure as it gets brought in Kubernetes.
Yeah, I second that. One of the main reasons I think Kubernetes has really skyrocketed in adoption is it is focused on a DevOps user experience, and it aligns itself with things like inline volume provisioning. Dynamic volume provisioning was one of the first things that Kubernetes brought in from a storage perspective. It just completely makes sense because people don't want to do out-of-band storage provisioning, and so some of the things that we learned there were immediately applicable to CSI. I think exactly what Clint said, there was a lot of lessons learned in the early days of Kubernetes and supporting external storage drivers that actually made it easier to design CSI and now implement it.
So it seems like there's two themes I'm hearing. One is the abstraction, so the orchestrators don't have to build drivers for every storage environment out there, right? That's one.
Right.
The other is that developer user experience, right? What would be some of the other major themes and pillars that are reflected in CSI now?
I think if we get down to the technical level of it, CSI is built differently than other interfaces that people are used to in the past. And what I mean by that is it's been built by the community, essentially. The container orchestrators, where we introduced this earlier, they actually founded the CSI project. And the idea there was it's an app-driven interface. Mm-hmm. So the container orchestrators represent the applications, and they're defining to us, I think sometimes the storage side of the house, like what these applications need. And it's the COs, it's the Kubernetes, it's Mesos, Cloud Foundry, Docker that all work together to say, here's our common needs to support our applications, and here's an interface specification that we'd like to implement in a contract, and that essentially has been ratified under the CSI project.
Yeah. So and exactly that, and in addition to describing to the storage implementation in the back as to what the application needs, it's actually also communicating control path decisions that the scheduler is making. So it lets the storage system know where a container is going to be scheduled and at what point the volume needs to actually be attached or provisioned or mounted. It gives us fine-grained control so that the storage systems can actually do a better job, and without that, the operator can be left with having to go in and either work around orchestration gaps or work around the storage systems not actually understanding what the scheduler is doing. So this really controls the storage systems to operate in a way where the system operator doesn't have to go in and clean up.
And I think there's another aspect of CSI is, like Go said earlier, like it's lessons learned. We've done different interfaces, and one of the key things is just making sure that storage is stable in the container ecosystem. When you lose your data, you've got a really bad day, and everybody knows that. And that's why storage is one of the most critical things that we get right. So we are very happy about all the collaboration that's taken place among the storage companies, among the container orchestrators, and I think that we're ending up at a very good place with this with CSI.
So obviously every storage vendor is different. Every storage vendor has a different approach, and a lot of, I think, what I'm sensing is that CSI has to think about abstracting, right? Abstracting it so the user has an interface that they can understand and that they can use with the orchestrators themselves. So, but how do you create these abstractions? You have to, so they're generally across all the storage environments, or do you have to think about them one by one to create abstractions for each one? And I'm curious on your thought process behind that and how that evolved over time.
So that's a great thing about this community is you have Portworx and EMC and Diamante and other people in the storage ecosystem and the orchestration ecosystem. We came together together as part of a storage working group and kind of really ratified what this interface would look like. It took a couple of months, I think, of going back and forth, in-person meetings, collaborating online, calls, to make sure that the storage implementations were properly represented. Because let's face it, there are a lot of different storage implementations in the back end. You have SAN, you have SDS, you have network attached storage. So this interface has to cater to really a wide variety of storage types, and at the same time, the orchestration and the DevOps user experience was also taken into account. So it took a couple of months to develop and design what the interface would look like, and then a few more months to actually implement it, test it out.
Yeah. I hate to use the word abstract again, right, and overuse it, but I think that's a key aspect to it, right? There's certain things that there's a common denominator, like among all the storage platforms, in terms of the key semantics that you're going to expect with volume functionality, because that's what CSI is providing. And I think those get nailed in the spec. I think where it is open a little bit in terms of the differences between platforms and what, say, Portworx may provide as value, or what Dell EMC or Dell Tech may provide as value, has to do with some of the parameters you can also send. And so the implementation by a CO is where that value is actually provided at that point. So it's like we're passing through opaquely some of this information through CSI to a CO, and it's up to the administrator and the Kubernetes operational team to configure Kubernetes to say, oh yeah, this platform in the back has these features, and I'm going to create what Kubernetes calls a storage class that makes it simple for my user to consume. So as a practical user experience, an application is going to say, hey, I want a platinum level disk, and the Kubernetes admin, Kubernetes operators are going to pre-configure that based on what they knows in the background. Maybe that's Portworx, maybe that's Dell Tech, maybe that's Red Hat's platforms, maybe it's GCE. There's some details that the operator or the admin needs to know, but it's very, very transparent to the consumer.
Yeah, and that last part that he mentioned is very important. The notion that with a storage class you can have different types of backends. Actually, the different types of backends could be even different vendors or potentially even different clouds. So this starts to give you the building blocks to have either a heterogeneous environment, or I would say more importantly, a hybrid environment. So you could have some of your storage backends come from public cloud, you could have some of your storage backends come from on-prem, but the user has a consistent user experience, and the operator gets to decide how they want to build and scale their environment. And I think this is really what customers are asking for: flexibility, give programmatic provisioning, give the end users the control.
And I think what's really interesting, it goes back to the point we said earlier, if it was up to the storage companies to create a spec, we'd be in disagreement for years. And that's, I think, some of the failure of previous specifications or standards, is that they become very, very detailed because they're trying to capture every single aspect and create this common denominator for a lot of different parameters. And so keeping it simple, focused, and then having a parameter section that's opaque makes it so we don't have to go down that discussion, and it really leaves it up to the Kubernetes admin to create that level of portability for their users.
So going back to CSI's original scope, tell us, I'm curious about the technical architecture behind it. What were some of the considerations, and how's it reflected in the technology itself?
I think what we'd learned in the past is that, and based on technology changing over the past 5 years or so, that interfacing two things together and having two discrete components figure out how to talk to each other is best done through, say, RPC calls, and best done through a middle specification or handshake that can be worked on and collaborated on. And that thing should be very simple, and that thing should be able to work across many languages. And that's been the ideal goal for REST for a long time, is, hey, I want to make it so that when I develop a REST interface, I can immediately take advantage of it in different languages. So over the past few years, I think there's been a progression towards GRPC, and that's enabled, I think, a very quick iteration between discrete components to agree on how they're going to function together, and to make it open to a huge ecosystem of languages and platforms.
Yeah, what that also enables is to allow this to evolve as a service-oriented architecture, where it is by definition loosely coupled. And what's taken into account in the specification too is failures happen, so you have to be resilient to that. So you could have potentially crashes across different calls, and how do you recover from that, and how do you come back to a known stable state? And so that sort of the state machine is probably too strong of a word, but that is sort of encapsulated in the specification and the implementation.
I think another interesting aspect to it in terms of lessons learned is, CSI is going to do the basic functionality very well, and it is going to introduce some new functionality too. So with CSI, we're including raw block devices, which are also volumes. So typically we've been advertising file systems to containers, and with CSI we're now able to actually advertise raw block devices to the same containers. And that opens a whole new door for new possibilities for different types of applications. If you're a high performance application, maybe you don't want a file system below you. If you're a clustered application where you want to have containers on different hosts sharing a block device, you're going to need something that's raw block. So there's actually new functionality as well, which is what was considered, like listening to the community, hey, let's do something better, but let's also add some really useful things that have been requested.
That this obviously this is CSI 1.0. Part of this working group is to continually evolve it, and we'll be looking at adding other types of functionalities, maybe enabling different kind of workflows. There's a lot of things that people want to do when they're managing stateful applications in a container orchestrated environment. For example, blue-green deployments come to mind, or doing things like DR and snapshots, and all of these things are, we don't know what it would look like, but I would imagine that CSI would have many iterations that would have some influence in this, or implementation would happen in part of the CSI 2.0 and so on.
So you're using GRPC, that's correct?
That's correct.
And the predecessor to that has essentially been REST-based APIs, right? Why is GRPC so critical, in CSI?
GRPC is based on protobuf, right? A specification or a way to define how a communication layer is going to occur. And this protobuf is a way that you can communicate easily back and forth between components, how they're going to predictably communicate with each other. So this is something that, like a technical document or a technical spec, that we can actually collaborate on from a storage perspective and also from a CO perspective as code. So as we have discussions, we can capture these discussions in more than just a JSON definition. We can capture them in like a contract, and that contract immediately becomes available in a lot of different languages, and it opens up the, it kind of solves the problem for us figuring out like how to take a REST interface, how to build object models around how to capture all the different objects, and then how to package those up in different languages to make them available. So it streamlines the process dramatically.
Yeah, exactly. And in a language-independent way, it allows you to encapsulate more complex data structures than you would otherwise do with traditional REST interfaces, and you can build more of a workflow on top of it, and it's not just a request-response-based system, so you can have a more complex protocol going on top of gRPC.
I think that the REST area is really interesting. People write books about how to take REST and make them available in programming languages, make the interfaces available. Swagger and a lot of the projects like that are wrapped around that concept, and I just think it's you really have to have a good reason to create a full REST object model and expect that someone's going to do implementations around it nowadays. I think RPCs and gRPC just gives a more native approach to connecting components together.
So how do you consider consuming it yourself? I mean, if you're going to be thinking about CSI, if you were using it yourself, or I don't know if you are, I'm sure you are, how are its use cases evolving kind of from your own perspectives? Like, are you using it internally? Are you thinking? So
both EMC, Rexray, Portworx have implementations of CSI. We do use it internally already. Note that the CSI first public implementation of it will be in 1.9, which I think will be alpha in December. and we'll both have support for it, but we've been using it internally, testing it, and making sure that it covers all of the various corner cases that it was designed to cover.
Yeah, this is a really important phase of this, like the validation of the spec. We've both been involved at a coding level and a discussion level for a long time in the project, and coding-wise, like, it doesn't mean anything, or the project doesn't mean anything unless it works.
Right.
So essentially, Portworx, Dell EMC, VMware, like, we're eating our own dog food. We took on the burden of validating, being in these difficult discussions, and helping get the spec and the project to where it is. And I think that we're kind of leading the charge so that we can make sure that it's going to be useful in Kubernetes 1.9.
And I think in the implementation, just to point out a few other companies that have been working on this, Diamante, Red Hat,
Absolutely.
and so there's been a lot of contributors to the actual implementation of it. So the point that I'm trying to make is that it has been already, it's seeing mileage within at least the developer community, and we've been eating our own dog food.
And I think the ecosystem is going to grow very, very quickly around it. And whether it's because of GRPC, there's others in the community who are stepping up to create libraries that are helper libraries to help you implement it. We have one called Go CSI. I think the community is going to rapidly embrace this and start using it as a standard moving forward.
So what's your release schedule going forward? How will you be managing that?
So, well, one beauty of this is now none of the storage implementations are in tree and are tied at the hip with the Kubernetes release schedule. So Kubernetes gets to maintain its own release schedule. Like I mentioned, 1.9 is due mid-December. We will have a coinciding release, at least from Portworx side, where we'll support the alpha implementation of CSI. Our implementation is in openstorage.org. Again, it's usable by any backend storage provider. I'm sure Rexray will have one at the same time.
Yeah, Rexray has had CSI support for a couple months now because we've been validating it through Rexray and through the Go CSI project. Platforms that we most recently announced support for are Scale.io and vSphere, so VMware's vSphere platform. So we will follow the release cadence, and it is great that CSI is developed and inside of, say, Kubernetes. I think inside of Mesos in the next month has been the commitment, and then Cloud Foundry and Docker should be soon after, I'd assume.
Okay.
Yeah.
So that's the progression you'll follow.
Well, it's we're involved in the project,
Right.
but we aren't the project leads.
Right.
That's Google through Kubernetes. That's Mesos and Mesosphere, Cloud Foundry, Docker, and it's up to them to figure out what the cadence is. But the good thing is that as storage companies, right, because of this extensibility, I think what Go is highlighting, like, we can make sure that our functionality is bug-free and fixes are maintained, and we're introducing new features that come out for our platforms independently of the COs themselves.
This is so new, but any use cases that you see as, giving people an idea for how CSI might be used?
So the good thing about this, I think, is ultimately to the end user, it's the same use cases that they've been deploying, the same type of stateful applications. Again, this enables them to deploy Postgres, Cassandra, MySQL, Kafka, Redis, whatever application that they've been deploying today. It just makes the experience a little bit easier, gives them the flexibility to go to different backends, gives them that stability.
Yeah, I think it's going to be much of the same for right now because we're focused on similar, but I'm really interested to see the progression that happens in the COs, because in Kubernetes, like in the storage special interest group, there's a lot of storage companies involved in that discussion, and a lot of that's because everybody wants to get their driver into Kubernetes, and
yes.
I think as CSI is embraced and it's available in there, I'm looking forward to some of the conversations changing, because it's going to be more about how do we actually enable these applications versus, okay, like another storage company wants to get in the tree, like, should we do it or not? So I'm looking forward to exposing more and more functionality to applications, not specific to a storage platform, but just generally how does Kubernetes and other COs progress in embracing this functionality.
This circles back to the start of our conversation where we were talking about the almost like, this matrix that people had to really kind of like have in front of them to understand, what drivers are supported and, what drivers are not in terms, with container orchestrators. Now they're still using, now they just have an easier way to do it, which kind of like allows them to take more risks, allows them to try new things, and not have to kind of then go back to the drawing board every time.
We're both in the storage working group at CNCF.
Right.
That's another group that's just focused on looking at what's going on in cloud native with storage. And there's a landscape that the group created, and it highlights the complexity right now that the users need to think about. And there's about 100 different storage plugins for 30 or 40 different platforms in the ecosystem.
Gosh.
And what that tells me is there's overlap.
Yeah.
And for a storage platform, there probably shouldn't be more than one plugin.
Yeah.
Right? There should be one that says you're a cloud native storage plugin, and this is going to work across all the COs consistently and deliver similar experience. And then it's up to the COs to differentiate.
Yeah, and like anything else, the less code you have, the more reliable things are, and that's really what this enables. Having more consistent way of being able to interoperate with different backend providers without having the 30 or 40 different drivers. That's a key thing to getting stability and making it easier for people to deploy applications and have the confidence that it's not just going to crash and burn.
Well, this has been great. Thank you guys both for taking some time to give us a bit of a deeper dive into CSI, and look forward to watching its progress over the next 6 to 12 months, and seeing it mature as this is extensible environment for multiple different types of container orchestrators. So thank you.
Yep. Thanks,
Thank
Alex.
The New Stack thanks the Cloud Native Computing Foundation for sponsoring our podcast from KubeCon plus Cloud Native Con in Austin, Texas. Learn more about cloud native technologies and the projects that are defining modern application development, deployment, and management at cncf.io. Listen to more episodes of the New Stack Makers at thenewstack.io/podcast. Please rate and review us on iTunes, like us on YouTube, and follow us on SoundCloud. Thanks for listening, and see you next time.